Hi everybody, good morning. I was planning to do this 2 weeks ago and I was busy and now today a bit free. I said let me do some rooms. So log analysis with SIEM. Learn how SIEM solution can be used to detect and analyze different type of munition behavior. I think this one is type of TryHackMe SOC. It's only subscriber so everybody can read if you want to read. So any modern SOC analyst must be able to efficiently use SIEM to analyze and correlate logs while quickly identifying malicious activity and compromise asset. Equally important is understand the different data source behind the logs and how each one help you see the full uh, picture. Okay, learning objective of this room is discover various data sources that are inserted in the SIEM, understand the importance of data correlation, learn value of Windows, Linux, web, network logs, practice analyze malicious behavior. We have three labs here. We have Windows log, we have a Linux log and web application log to practice on them. Some introduction. Sysmon, most of the room is using Sysmon, not the event. The lab is Splunk. When you start it, you just go to this new tab, and when you do this, basically, my experience just restart the machine. Let's kill it because it happened to me when I was testing it. Just we can do the rest. Where is start the machine again? That's what happened. You don't waste too much time on it. Just leave it to start again. Let's go first, for example, the introduction. SIEM should play a vital role in every security operations center and is so can assist day-to-day life. Let's take a moment and understand why SIEM is so viable. Centralization, because that's what's the idea. You put different logs inside like in this room using Splunk. One of the first things that makes SIEM so helpful for SOC is centralization. Instead, or this is echo things of TryHackMe as echo. Instead of checking logs in different places like network device, cloud, identity, you can put all of them in one pot like in Splunk or something. We have two SOC level 1 analysis TED and Emily TED work in the SOC with SIM solution, but Emily doesn't. The suspicious spike in network activity is an example. Malicious command was detected in a host. With a SIEM-TED can investigate both alerts from a single platform. He has access to log for IPS endpoint and other system. Basically, this is you have all the logs in one place. The other one doesn't, so you don't have a full picture. Correlation is, of course, one log gives you something. For example, the process was created, then another log for network, and like when we do Event Manager for Windows. Event log. Another core strength of SIEM is correlation, the ability to link separate events and piece them together like pieces of puzzle to form a complete picture. Let's walk through a scenario. For example, you receive an alert in your SIEM about intended network discovery activity. The only information you have is an IP address of the host performing the scan, nothing else. The alert comes from IDS log. There's not much to go. So we have, for example, alert received, identity provider, user info, system log, host info, network log, give you the IP address, and you correlate between them. You can check Windows event log or Sysmon by correlating this with IDS alert and build a context. Historical event, of course, SIEM also allowed to look at past event, not just current activity. This help you spot pattern or thread that may have started earlier but weren't noticed at the time. Like going back in the history, so for instance, if you get an alert about unusual login location of a user, you can look back at historical logs to see if he has logged in from that location IP before or not. So you have some kind of history data. Let's go quickly in what is the process of linking data from multiple sources to identify relationship. This is like a correlation stuff. The correlation. I'm not asking echo. It's like CompTIA plus question. What is the process of collecting and storing log data from multiple systems and sourcing to a single unified location for easy analysis called? This is more like a center. what to call it, center event centralization. Is there center? Where is the have correlation? This is centralization, so it should be centralization. Let's see. Let's see if our machine working or not, so we don't have problem. Where is that link? Let's see if this one work now. Sometimes works, sometimes doesn't work. But TryHackMe. Why? Because I'm doing a video, so you're kidding me now. It happened this way, so yeah, the only way is shut down and restart again. There's no other way. Bad gateway engines, because they're using this reverse proxy west, so it's not working. Again, let's terminate and wait for. Let's not start it automatic this time. Let's wait for a moment. Let's say log source overview. Let's explore the log source that analysts can come across in the SIEM. So basically, more network host. Every organization has different types of resource from which logs can be collected into a SIEM, such workstation, server, network device identity, provider, cloud services, voice application, and more. It can be helpful to think of this as a tree, where the organization is the tree itself and the roots represent the resources that make up this tree. So basically, logs come from the host. For example, host-based log source. Host-based log source came from individual devices within the organization, such as a workstation and server, things like that. And let's not forget our machine, because our room is basically in this start this machine. So the host basically, yeah, activity account management, system event authentication, process auditing, object access, detection of malicious executable, and all that things in the host. Then we have a network, for example, detect port scanning, detect suspicious external connection to unusual port, detection of unexpected login attempt, and brute force. IPS, firewall, router, monitor source, DNS, proxy, VPN logs, and things like that. Web-based log like Apache, things like detection, SQL injection, detect web shell exploitation, weblog, firewall. This is what WF firewall, web access firewall, what they call it, API, gateway log, weblog, log, load balancer, CDN logs. So this is a network. Time pitfall. What time pitfall? One common challenge analysts face when working in SIEM is time. Specifically, how time is recorded across different sources. Most of the time is UTC, universal time, coordinated universal time. One common logs can come from system in different time zones. Some can be UTC, other in local time, and some may not include time zone. It is important to understand that your local time can be different from the time set in the SIEM. Let's say you're working in UTC -2, but the logs Splunk SIEM are normalized to UTC +2. If it's a PM for you, those same logs at 1 PM. So the time in log normalization. Different log come in various formats. Some are JSON, other XML, or even plain text. Each system we need to extract here. You can see now in the logs they give us later on. So the idea is to convert all this format into a single consistent structure. Okay, this is more like how to get log. For us, we already have a log. So what is the process of converting log from different format? They already said to it now. They talk about normalization. And then which log source type can be used to detect the execution of malicious script? This is what weblogs. So what? Which log source type can be used because it's a script, so is a not a network, is running inside the machine, so it should be the host based. Now let's see if we're lucky, or we need to pause this video now. I think we're lucky now. It doesn't give bad gateway anymore. Okay, Windows logs, our friend. Yeah, I like Sysmon. The window, this Windows window, it's also Sysmon easy to remember. Log ID 1, 2, 3, network 3, 11 what registry. But this one like 7, 6, 9, 2, 5. The Sysmon is I like the Sysmon addition, and in some cases even primary log source and Windows is Sysmon. It is an incredibly powerful place that logs a wide range of activity. For example, here, let's see what we have here. It's starting. Let's see what TryHackMe was doing here first. Uh, Indexes. Oh, it's slow. Oh, that's the index they have. Tax 64 and the one they told us for the room. So we know that. So you can go there. Search and reporting. I don't like Splunk. I like the other one. What's the name of it? Change the time to all time. Yeah, we can start with just get all of them. Uh, this Splunk, what's the other one? The other one I like it because when I click there, I can add it in the search automatic. Splunk, you need to type. Hey, the host. So we have WinFed, Deception Demo, wherever. Source type we have access combined. So we have the event log, the syslog, and Linux secure. This one 60, so most of them in the event log windows. This is the combined log. Okay, good for us. Yeah, so for us, it's just, let's not go there. Here they give us an example, for example, malicious process execution. Here's they using event code 1, so that's a sysmon. So let's consider a situation where you receive an alert about the execution of a suspicious encoded PowerShell command. Most of the time that's how it starts. So because it's PowerShell, you're looking for process creation, you search for PowerShell and the encoded command. You can now be doing analysis activity. How will you use SIEM to analyze this? Let's try using Splunk query to see what useful information can be. I don't think we don't have. This is not the same as the task because our source this one. So I don't think they just given it for to look at it. Then we can practice in later on. Let's follow this example quickly. So basically, yeah, you say event code, process creation, then the table structure, you get the time, computer name, parent user, parent image, parent command line, image command line, and then we have, you can see in this image, they tell you detect the host name. Then we have what's this? We have the node here. What are they calling for PowerShell? Where is the that's the PowerShell. The command start by node, and we have update.config from the public folder. So this is suspicious, and you have base64 encode command. That's nice filter, like a PowerShell and encode command. That's nice to remember in the future. Now, suspicion network activity, so you're going for event code 3. This is sysmon. So because now wherever you do, usually when you the process get installed or something, you start connected to the network. So we get in network event code 3. We can focus on that computer name. We already know it, and then we can check and we can see, for example, towards there is a process now, malicious process establishing network connection to the source IP, the local victim machine, the port and external, and we have the protocol and destination port. So this part of the investigation. Win event logs, the one that we don't like, we can see 4720. This one, what it do? The most commonly viewed and referred are security log. Yeah. let's break down why these logs are so important. Okay, we hope you still remember our example with WinHost. The SOC analyst started a new shift and was handed information about suspicious activity in this host. Within just a couple of hours, another alert came in from the same machine, this time about a user account creation. Because user creation, you go to 472, 4722, I forgot now. I think this is a creation. What this one update, or is still present in the host. We need to review security logs to detect what happened and share this information to SOC level 2. So tell admin create account backup. So 4722 is or the enable. So 4720 is user account created, and then you enable it for 722. The account was backup. So we can see now Windows system logs. For example, this is like when you do persistence. The logs record event generated by the operating system and its core service. They help detect various events related to services, system level activities, and potential errors. These logs are an excellent place to look for potential persistent and privileged escalation attempt. Let's examine activity on our compromised host and try to, let's see if, I don't think we have these things in, I know we can't use that index. Let's see if we can. I don't think these example are part of this now. I don't think so. Yeah, it's not part of this room. They just example. So we're looking for 4072, which indicates service creation and service start stop. So we're looking now for services because the room, I think we're looking for scheduled task later on. Scheduled task, not the service. So they just give us an example. It's good to know how to do this query. So we have the event, then you create a table with the time, event code, oh la la la. And then if you look here, we find now 472, which one? This one. This is user creation, I'm confused. This one, the event one. Service create level 7045, and then the enable start at 7036. And you can see service local system, and you can see user and the username update local. Usually a strange place to put the service there. And yes, a message. I like this idea to put the message there. I think we need to practice this message there. Let's practice else. In our case, they tell us use index 4. So let's go to, we have index 4. No, not index 4. Task 4. We have 9 because we are in the event, Windows event log. So we already have the host Win105, so we are cool there. So this says that you are a SOC level 1 analyst on shift and have received an alert indicating a suspicious network connection using port 5678 on the Win host. So we already have the filter in the host, we have a port, and it's a network connection. So if you remember here, we talk about network connection. Where is the network connection? Event code 3. Let's see if we have the sysmon here. Where is the event code? Not this one. Event ID, not this one. Event code. So we're looking for event 3. Let's click. So now we have 70C event. We know the host. We're not filtering on the host. But we have the port. So we have the event, we have 76 event. We can filter because it's already give us the lead. We have the port 5678. Now where is the port? Source port, more destination port. A B C D. Where is the D? Destination port. What it said? 5678. 5678. We click on it. We lazy, we don't type us. Now we got this. We can make it nicer if we want. Are we lazy today? Let's not make it nice. Uh, he said which IP address was the connection established with? You have computer name destination IP, so we can get this. We're not too much fancy. When things are easy, let's take easy. Which process is initiated this suspicious connection? You can see image. Now suddenly I want to do things fancier. Let's do table process, not process, image uh, destination IP. What is the question they asking for? Oh, the hash. Let's not get the hash later on. Why the image is empty? Really? You're kidding me? Oh, with a cup letter. Yeah, it's just if you want to look it in tables. So SharePoint, we know it's so we know the. Did we answer the question? No, usually when you do this, usually because when you do investigation like that, it's also get who trigger it. So, for example, I can go with that if it does give us the process ID. Ah, we have process ID. It doesn't have the parent. Uh, we're not extracting. We only have process ID, no parent. So we can do fancy stuff. Image. Let's do process. I wanted to. No, not really. I don't want to confuse it. The logger, not the details. What? Why the process ID again? Okay, let's do this. Now we need to search for this SharePoint. Sorry. No, they tell us look for this MD5 for this. So we need to, because we know it's SharePoint. We can just not even. Let's say how we start, because you get. Um, let's see where these things start. Uh, share pool into the XE. This process. Uh, uh, oh, we have a command line, so we can do nice things now. Oh, give me a second. I forgot what I was supposed to do. Source type. Does it look in the system and all of that? I don't think we need to correlate anything. It's still in the same source type, so we can just leave it in task 4. I don't know why the question said leave it. So now we're tracing this SharePoint process. I mean, let's just make a table because I need to look to see what's going on. SharePoint. I'm interested in command line. Command line. What else? Why it give me that funny things? No, you're not supposed to do that. I need to do them brackets so you can search everything. Image. Oh yeah, parent command line. I need to look command line. I need to put parent command line so we can trace them. Oh, do you have a parent image? No, we have some nice stuff. Parent image, so we can see what. And now we have a parent process ID and we have a process ID. So the image, and then we have the parent process ID and the process. Oh, the ID not couplet. That's why before didn't come. Uh, what else we need? We can get event code because we can know what exactly happened. Event code. Now let's see what's going on here. Now you can see one is a process creation. What I'm getting now? Oh, so you can see now is a task was created here. Now, but for let's sort uh, plus time. Why it showing me Google Chrome? What's going on here? It was downloaded by Chrome. What exactly happening here? Why I'm getting the Chrome? Let's view this event. What exactly this event is for? Is a download. That's what it download. That's why I'm getting it from Chrome. So it was downloaded through Chrome. That's why we see this Chrome. So it was downloaded by Chrome, and you can see the processes ID. Where is the process ID? And then what happened? Explorer, open it. Process ID, parent. Let's get parent. It's wrong. Parent process ID, because that's how you correlate who triggers who. For example, here we have a 5240. It triggered the one for 60, which triggered the share point here, and then after that, no, where is this 700 came from? You can see the 146 here. This so this one trigger this one because it become a parent of it, and then this one, when they run the SharePoint, also create a schedule task here. Huh. Now where we'll get now this the MD5, you get it when the process was created, before it get connected to the internet. Here it was downloaded. One was created. That's the one that came, and that's the 11 SharePoint connected to the internet. That's why the port, that question of the port. So we could get it somehow here. It should be in a post creation should give me the SharePoint event. No, not you. This event. Let me view this event. Because if the process was created at event code 1, this code 1 which should give me the information about or this one, any of, no, this is the one that should give me the MD5. This one should have it. So it's SharePoint image there, task. Uh, it was downloaded. No, this is when it was when it's running. When it run, it will give me the MD5. Yeah, when it's event ID event code 7. Task. What's the next one? Event code 1. Yeah, 7. What is event 7? This is the MD5. Uh, so process creation, you get the MD5 on it. I don't know why TryHackMe, the Hindi said need to correlate it. It doesn't. It's inside the same the log, the task for log. So we go, and then you can see now what happened later on. It was this. It was what's the next question? What's the name of the scheduled task that was created in the system? You can see it was created here. So uh, Office 35 install. Uh, you can get this event, view this event, or you can be lazy, for example, because schedule is yeah, you can see it's there. It was created. Or usually, if you get lost and you don't know to answer this question, you can just go there, task for, search for like because the command usually is sch schedule, or if you remember the command, usually you just because to create an email schedule task, you need to run this command. So basically you can just do that and make no preset all time, and just search for the shed command, and you can get it the way. So it's different way you can play with the logs. So you have a schedule task. A reason why I like to like what we did now. Suddenly it disappeared. Where is my where is that the whole shalada index? Reason why sometimes it's good to do these parent things, because what happened now? It froze. Okay, let's go to the next one, the log, Linux log. When we are analyzing Linux system in SIEM, you will often start by looking in two key log sources: authentication, of course, SSH login and things like that, and then the syslog, which captures system level event. Here you can monitor service restart, cron jobs, background process, and all of that. Authentication log, for example, yeah, you can do, for example, source log. For example, if you know the user, the process, for example, SSHD, for example, they give us an example. You can see source log, accept password, accept failure password, failed. So successful login for Ubuntu user from that IP failed, and the query is that's nice query. This one define the process. The next one, privilege escalation. Usually you can go look for SU. That's why you can just sometimes search with keyword that you know is SU, do things like that. Here you can see the use SU, deception demo SU, confirmation user switch to root for SU, then system logs persistence. For example, now you're searching at cron or cron like small letters and different logs, so you can catch all of them, and then you do the search in for keywords, and here you can see that it was created .ssh, but because you're looking for .sh keyword on it. Let's practice and hope something is not messed up in our log. I don't know why it froze. Now it tells us to use task index task 5. Let's try that one. It froze for whatever reason. Let's see what's going on. So we have task 5. Task 5 has two. We have a syslog and Linux log. So we are in the Linux system logs. We have 78 logs, and then we have all this data. We have two hosts, deceptive demo, so we can practice what TryHackMe was doing here. So let's see if they're because this is user Ubuntu, we can practice. I think no, there is no index Linux. Let's pull it all. Let's see if this one works. Yeah, this is user Ubuntu. I remember it. So you can practice this one, but let's practice in our live system. They tell us you are SOC level 1 analyst on shift and have received an alert indicating possible persistence through the creation of a new remote. So we have a user, so we can call that in Ubuntu server. You have to dive. So the question is, when was the account SSH? What was the time for remote account creation? What is the certification privilege, IP, and so if we follow this one, which task we are in? We are in task 5. We can, yeah, it's fine, but let's limit the search. The user, we know it's remote SSH. Yeah, we can leave the source authentication for now. What? Oh, what's wrong with you? Why is not he has a problem with the user? Why the user is a problematic? Remote SSH. What was the timestamp of the remote SSH account creation? Maybe if it was created, it would be inside the system, so it will not be a process. Why I'm putting password? What's wrong with me? So we have two events here. What's two events? We have three events. When you search for this user remote SSH, you find this user root pw. We have a command. It was in the home directory of Jack Brown. User switch to root is clearly switch to root here. So let's say user root command user binary user add remote. So it was add this. What's the time? The first this is 9:57. This is the earliest, so it's going up. And a new group, because when you run this command, it will create the group and create the home directory. So the start was here, so the time for it will be, what's the format of the time that side? So we have that, then we can just take the, yeah, you can see plus 00, it means UTC time, so if we don't need to change anything on the time. Then which users have established their privilege to root prior to the action from the first question? This one you can see it straight here is running in Jake. Is switched to Jake here, but we can follow this story. How to do that? We can leave. It means before remote SSH, we can go to like this one, the one that would start looking for a process SS. Now we can get. Let's make it nicer. Where's the username fields? User remote host. It's only one user, Jake Brown. Okay, remote host type. So we can do what exactly we can do. I'm looking for this because a session open for user Ubuntu. What is Ubuntu here? Why the user? This log looks strange for me. User Jack Brown. Why is the other users? And it's all 100%. Why it doesn't pick up Ubuntu? Is there another user field? It's only that one. UID is not. Let's try that one. You can see the users in the Linux box. But why Ubuntu is not pick it up? Because accepted password for Ubuntu from this is authentication log. These TryHackMe logs look strange. Any case, we know the user is so we can look for let's do this. I like this. Why is not copying now? And let's get the user, because the user, we know the user from that Jacob Brown, the switch. Well, that's one. It was a switch. Okay, so we have accept password, fail, 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 and then fail repeat. Accept what's the question? From which IP address did the user from the previous question successfully log in the system? Yeah, it was accepted here. Let's see. Where is the IP? From this one. And then how many failed login? Failed login, you can see it now. We have 1, 2, 3, 4, and this one is said is repeated. So basically, we're not counting that one. So we can go to that one. The next one say which port the persistent mechanism configured to connect to. So remember, now they told us in this room you can follow, for example, here searching for cron. So we can just do this if we're lucky. I think this one, it will not give you information, to give you zero pattern. Let's look for the cron without this filter, and if you look at that, we'll find it's because our cron is not same as this filter. This one is looking for .sh parent, things like that. But if you look here, the what's happening here in this uh, it was, but this cron is in deceptive demo. What's going where? TryHackMe. Wait, task 5 host deceptive demo. That's funny. What's the question is? So they switch. Oh, deceptive demo is the Windows Server. Okay. So if you look here in the command, it said to connect socket connect to 10.10.33 import 7654. Splunk, sometimes I get confused. The next one is we go into task 6. Let me clear this one. Task 6. What we have in task 6? Oh, task 6 is big. What exactly is source type? Combine. This combining the whole logs. Okay, let's see first what task is talk. Almost other important data source for analysis include the web server. Okay. Every organization has its own website, therefore web server running it. Logs from this web server are collected from Apache, Nginx, and all of that. For example, here detecting brute force activity. Here they detecting through Apache, so basically they tell you URI path w-login Apache method post, so you don't and also the idea, because usually the hacker in a short time they do brute forcing, so 5 minutes look for beta. Let's see if we can get this the same as a room, or it's not example for this room. Task 6, let's see what happened. Oh, we have it, so it does work in this room. So we can see a brute forcing. Of course, you can, if you don't want to fancy this brute forcing, you can remove all of this. Uh, if you don't know this command, doesn't mean you can't solve the room. We can just do that and then do stats count count by where's the URI path? URI uh, what? Not stat, sort. Yeah, we can get for example, if you don't want to do fancy queries, you can see wlogin was hidden 743 times. So you can do that, or you go fancy with you go fancy like TryHackMe, and you go that. This one is nicer. To give you all the information you need, and it will help us solve the room quickly. So as I said, you can see the brute force utility Hydra, for example, in this case, in this example, TryHackMe, the attack IP, the targeting wlogin, and all of that. The next one, possible web shell, because web shell, this one, uh, status 200. Yeah, you're looking for PHP, PHTM, ASP. No, I don't know why mixing this, because this is if you are in Linux. No, if it's in Windows, you can have both of them. Sorry. And GSX and uh, can we use this one? Let's see if we have this one can work. I didn't try it, so It give me there is no web shell in this example, so we call in this one. If you do this, it will show you 504.php, so we know it's a web shell. I think this is like a walkthrough. No, hold on a minute. No, but I get, but we already have in the combined, so it's not like we. Okay, let's go back to task 6. The next one is DOS attack. The shift is almost over, but don't rush to close your laptop just yet. A new alert has just come in, likely the last one for today, about a possible DDoS attack. When checking for signs of possible DDoS in Splunk, look for 503 not found. Oh, server error, which can mean the server is overloaded. Review for user request count and show time. I don't think we'll have this. I don't think TryHackMe did uh, simulation for this status, not status. What? Because we don't have this. What is it? Missing or malformed? No, not you. You don't put a bracket there. We don't have a DOS attack in this room, so it's good to see it so you can so. No, let's practice in ours so we can finish this room. So you are level 1 analysis and shift and have received an alert dedicating a spike in activity in the organization web server. Your task is to dive in the log to determine exactly what happened. It's a which URI path had the highest number of requests. Now if you look at this one is already give you, we'll use this later, but for us uh, if we want a URI path, so we have a URI path because let's not cheat. Let's go back to the standard. So if I go to the URI, where's the URI? You have two. We have this one URI and we have a URI path. Well, which one should use? Let's use a URI path. So if I do table, let's use the URI or URI path is the same the way it's set, and then we can just which one that we no not table the one that we do stats. Why I didn't remember it? We already did it now. Stats count by URI. URI path. Yeah, right. There is no. Let's do URI. Yeah, it's fine. Let's follow TryHackMe rule, and then we can sort count. And you can see if you do this, you can see it give you which one. For example, the biggest one is the W, that one. And then you have the main one, the cron, and you can see all of them. So we have now we know it's a W. And if it's web address, that's always what it is. They always come there. Then which IP was the source of the activity? Here we can go to this nice query. I like this one. You can copy that if you want to go simpler or you go fancier. Why not go fancier? So if I search there, now this one gives you client IP. Which IP? No, I don't have the IP. What we supposed to do again? Which IP address was the source of the activity? Why this query doesn't give me the answer? Client IP refer domain. What refer domain here? What is the client IP? Is it the source IP? Client IP, user agent, URI byte count by client IP time, client IP. So this is the source of the client. This one, it's straightforward, brute force. The tool is clear here. You can see WP scan. That's it's already here. WScan version 3.8.28. I almost get confused for a moment. Oh, WScan. It's good to save these queries in future in this CTF or something. You can use them. It's a nice queries, this one, to save them in your notes. Yo guys, hope you like it. In case someone please subscribe, and then yeah, thank you very much, and let's see what's the next room I will do. This morning any case, let's not go there. Yeah, I think that's it. That's the room. That's the Splunk. Yeah, if you have question, guys, let me know in the comment, and thank you very much, and have a good day.